Hello. We'll just give it a second, let people get in.
Hi, Rich. Hi, Demir. Hi, everyone.
How are you, Wallace?
I'm good, and you?
Very well.
Nice.
Hello, Varun. Hello, Ace.
Hey, Rich, how are you?
Very well. I've been stripping wallpaper all day in the new house. So, yeah, I'm covered in dust.
Congratulations on your new house.
Say again, sorry.
I said congratulations on your
Thank
new
you.
house.
Thank you. We haven't moved in yet. There's a lot of work that needs to be done before we can move in. New kitchen and whatnot. So a wall needs knocking down. So there's plenty of stuff to do before we get in. So yeah. So I'm double busy all the time. But yeah, I've managed to get away to come on this meeting, so it's all good.
Like I always wonder like how you take time out for like your family, then your original work that you do, and then Omdena. Because it's
Yeah,
really good. Like I recently
I'm a very busy man. That's the problem. Yeah.
because I recently like got the new job.
Congratulations.
So it's into medical field.
Nice.
So yeah. So Uh, it's been almost like a 2 months or something. So like the first month was very like there was nothing to do much because I
Yeah.
was learning the things, and now it's start getting busier. So
Yeah.
I
Yeah.
think
Well, in work at the moment, I'm not doing much machine learning at all. It's actually a software development project, and
oh,
I wasn't. I've never been a software developer. I know how to code Python. The program itself is written in Python, so it's not too bad, but it is quite difficult because it's a well-established piece of software, and when you come into it and you've got no idea what it does or how the architecture's been structured, it's very difficult to catch up. So a portion of it that I've been working on is going live next week. It's getting pushed into production. So that's why, last week, the meeting, I had to put it back because there's just so much going on in work at the moment. And then when I leave work, I've got stuff to do around the new house. And I've got Omdena as well. So yeah, my time is is taken up by a lot, but I like to stay busy anyway. So yeah, cool. So we'll make a start. I don't think we've got many people on today, but it doesn't really matter. I mean, I've seen everyone is working really hard. There's so many notebooks and there's a lot of activities, and it's great to see. Some of the experiments that are getting done as well is really good. So yeah, so on Wednesday, always showed us what's been happening so far in his team. And there was 2 more batches, I believe, that they were going to, experiment with and get the results. And I think Neville was one of the was leading on one of those projects. Wait, have you got anything to update at all with how it's been gone? I haven't been closely monitoring the Slack because I've been very busy. Let me just allow you to share your screen. But if there's anything you'd like to share, any updates from that, something that's come up since Wednesday, please go ahead.
Yeah. First of all, Rich, congratulations on your new house.
Cheers.
Yeah, it looks quite refreshing, to be honest.
Yeah.
The background.
Oh, this
Uh,
isn't in the new house. This is
oh,
my partner's sister. lives
Okay,
like
okay.
10 doors down from the new house. So I've just said, listen, can I just jump in because a husband works from home as well. So I said, can I jump in your office to do this call? So yeah,
Oh,
I'll give you a tour once the house is finished, like the before and after, and yeah, I'll show you all that because it's quite a big project. But yeah,
yeah,
but it's a very nice office, to be honest with you, in here. I'm gonna do mine are pretty much very similar, I think. So yeah.
yeah. Okay, so I misunderstood.
It's all right. It's okay.
Okay.
I like the way
Um,
you noticed my background was different though. Very
yeah.
astute.
Um, yeah, so about the project, as you mentioned, as you have mentioned, there has been a lot of work going on in the channel. And to be honest, it's a bit hard to keep track of like everything, but I have gathered around all the important uh, stuff from whatever that's been going on in the channel for the past uh, couple of days.
Cool.
So as we mentioned, as I mentioned in the previous meeting, we were almost done with the image augmentation, and uh, I mentioned that we will be moving on to a feature selection stage. And I also mentioned about the two data, the two extra data batches that will be generated, and they have been generated, but I will come back to it at the end. So regarding the feature selection, so a lot of experiments have been going on, and Wallace especially has spent a lot of time using ANOVA for feature extraction. So he tried to train a model on the top 20% features. So the features were extracted, like I said, using ANOVA. And he did a bunch of experiments, and so we were trying to find out the the sweet spot, are the number of keeping how much features, how many features can we keep that will give us the best result. And so we came up with these are the best results so far. So from the confusion matrices you can see that this zero class is the hem class, so this is the minority class of the dataset. So it has improved a little bit because the number of false positives have been decreased significantly. I will show the comparison in the next slide. Yeah, so this was one of the model that we trained before performing any augmentation and feature selection on the data. And as you can see, this is the hem class. So in the beginning, we the misclassification rate was significantly high. And to be very accurate, so out of the 100% of classification, 38 there was 38% chance of being 38% of the time the model misclassified the hem class. So that means that if a new instance, we want to predict a new instance on this model, there is 38% of the chance that that new instance will be misclassified. And then after the augmentation and feature selection, uh, looking at these numbers, we cannot see like significant difference, but if we calculate the percentage, then we can see that after the augmentation and feature selection, there is a 29% chance that a new instance may be misclassified. So there is almost 9 to 10% improvement already from the augmentation and feature selection. Um, so 29% is also not very good, but it is acceptable compared to the 38% misclassification. So this is just a comparison of what we started with and what we have right now, or where we are right now. And other than this, these are the experiments. So the two new sets of data, the one batch of data is we use ResNet for feature extraction. This was done by Neville, and then I think this was Darshan Pai. He also used MobileNet and he used it for extracting features. So we haven't performed any experiments on this one right now. And with the ResNet, there is an issue of too many features. So the features extracted by the ResNets are around 9K to 10K, to 10,000 features, around 9. So
Do you know what version of
people
the
are,
model? Do you know what version of ResNet Neville used?
no, that's I think Neville should have that info.
Yeah, cool.
So
yeah, it's no problem. I was just wondering because there's a number of them, and I think from my experience, the one that I found works very well for feature extraction was the ResNet 50. There is more. There's like I think the latest one is it ResNet 101 or something like that, but it was overkill. It creates a lot of features. ResNet 50 was the sort of sweet spot in my experience. So I was just asking the question just in case he's used at the higher number one. It might be worth giving it a try in ResNet 50. It gives it a nice middle ground. But yeah, just ask the questions and see how that works.
yeah, so I will ask Neville. I think Neville is in the chat or not. So I will reach out to him anyway to make sure which variant of the ResNet is he using. So at the moment it's quite difficult to run experiments on the ResNet data. Wallace has I reached out to Wallace and I asked him to like run a couple of experiments on this data, and he told me that he has already tried to do it, but because of the huge amount of features, the Colab environment is running out of memory.
Yeah.
And Neville also mentioned the memory issue a couple of times in the channel.
Yeah, I seen that. Yeah.
Yeah, so due to that, Neville has been, I think he has been able to work around, this experiment is not like very trustable at the moment. As you can see, the accuracy is only 57%. But we are trying to figure this out. So at the moment, there hasn't been done any proper experiment for this batch of data. And the best results that we have so far are using XGBoost hyperparameter optimization, and these results were obtained by Damir Zerniak. So he hasn't done any feature selection yet, but he spent more time on the hyperparameter optimization, and I think that has gave him a little edge over the other people's experiments, and that's why he has like 87%, the highest amount of score in our experimentation right now. So yeah, so it all may seem a little bit confusing at the moment, but yeah. So next in this next week we will be trying to implement ensemble learning, and we will also try to extract features for this mobile net and not extract features, perform experimentations on this mobile net database and this ResNet database.
Yeah, the mobile net one, that's one I've never used and I don't know much about it, so that'll be quite interesting to see. But yeah, it's not even one I would have thought of.
So I have the watched a video about it, and I think it is like a simpler model than VGG16 and ResNet, but it's often under certain conditions, situation, it outperforms VGG16 and ResNet. So
Cool.
yeah, so only experimentations will tell us if it performs good in our situation or not. But
Yeah.
yeah, this is the overall summary of what has been going on.
Yeah. No, that's really cool.
Yeah, so
Yeah, because
so the final point, yeah, go ahead.
no, it's okay. Go on. I'll let you finish first.
Yeah, so I was just saying that that the feature selection and hyperparameter optimization is adding adding to the overall performance of our workflow, which is a good thing, because now we know that we can rely on these two techniques.
Yeah, it'll be good. It'll be interesting to see the ensemble learning as well. Yeah, I think that might squeeze a little bit more performance out on the feature selection as well. It'll be interesting to see on that the ResNet and see if that can reduce the complexity of the data down, or the dimensionality rather. But yeah, it's fantastic work. Really good. I'm trying to keep up with in Slack, and I've seen a lot of people are contributing really good work. You're working as a team really well. Team 2 haven't been on up as much, but that's not really a worry, to be honest. I can't force anyone to work on it. So in the sort of background, I've been building a manual model. I've only done a very simplistic one, which seems to be getting similar results to what you're getting at the moment. But there's a lot of techniques that I need to include. I need to make like the model of the neural network a bit deeper and things like that. I've just put something together. I'll probably share that on Wednesday, to be honest. I'm not on the right laptop at the moment. It's on my works laptop, which is like a machine learning laptop, so it's all on there. I haven't done it on Google Colab or anything like that, so I'll share that, and I'll just show you what I've done and show you a couple of the techniques. A lot of them won't apply to your team because obviously you're doing the traditional one, but I want to, if team 2 are unable to, come on a Wednesday or a Saturday and provide some work, I'll do it. I'll fill in that gap as much as I can. But yeah, I think what you have done is really well, and the way it's organised, and you've got your experiment sheet and the results. It's really good stuff. I've seen that you had another team meeting as well the other day. I think it was on Thursday or Friday. I haven't got the recordings of that yet, but I'll take a look at that and I'll put them on the YouTube as well. I just haven't had the time at the moment, but yeah, I think it's going really well. We're on time, we're on track, and as I say, next week we can continue looking at the ensemble learning techniques, and then the week after that we'll start poking around the idea of how we can deploy this, and or at least write a proper report on what's being done and your experiments and whatnot. But I think that the deployments, as I've said over and over, whether it's 100, like it performs amazingly or not is quite irrelevant. It's something that you can have live for your portfolios, and that's what is important about the deployments. In real life, if you were doing this in industry, there wouldn't necessarily, you'd probably be using it internally with whatever company that you're working for, kind of thing. It wouldn't necessarily be deployed to the public. So it's not a big issue, but it's nice to learn how to deploy things and how to at least build them into a web app. Again, just to show people what you've done rather than just tell them about it. It's something that they can actually use. So yeah, we'll start talking about that, not this week, next week, and I think we're well on track. We've got plenty of time, and yeah, I'll get together some of the bits and bobs that I've been doing as well, and show you guys that as well. But yeah, well done always, and well done Team 1. It's been so far really good.
Thank you, Rich. So when exactly are we planning to start on the dashboard? Like, how much time do we have for the experiments?
I'd say you've probably got a clean 2 weeks.
Okay.
Next week, yeah, get onto the ensemble learning experiments and whatnot. The week after, that's when you should start to really close it up and pick a suitable candidate to deploy. And then on the Wednesday we can talk about, and on the Saturday, we can define a model that you want to use, and we can come up with suggestions of how to implement this into some sort of web app, Streamlit, Flask, or whatever it may be. We can talk about that then, and then you can save your model down, the best performing model, and we can implement that and build it into the web app. And it's not too difficult. Always, you created the dashboard for the last project, and it was fantastic. Creating a model, it isn't too much more difficult. You just have to build like a little you have to, of course, upload your model and use it sort of like an API, and then just build in where you can drag and drop a picture or something like that. But we can also it doesn't even have to be as complex as that. What I was thinking, I seen one a while ago. I'll have to try and find it again, but someone deployed a computer vision model, and when you opened it up, it had like a number of pictures at the bottom in like a reel, and you would like click on the dog or click on the cat or whatever it was, and it'd process and say this is a cat and a dog. Do you know what I mean? These were images that the model hadn't seen, but they were just there to click, and it would generate the prediction kind of thing. We can do something like that. It doesn't have to be overly complex. It's just to show it's the fruits of your labor kind of thing. And of course, in a couple of other pages, we can have a proper write-up about what we did, how we did it, what worked, what didn't work, and maybe a nice little bibliography as well to show what sort of research we looked at to come up with this particular model. A bit about the VGG16 and transfer learning and things like that. So yeah, it can serve two purposes, but it'll be a nice chunky portfolio piece for everyone on who participated. Do you know what I mean? If that sounds good to everyone.
Yeah, personally speaking, making a dashboard for this project should not be an issue at all. And I wasn't planning on telling it right now, but I have already prepared a kind of a rough dashboard for the project, and I have uploaded a dummy model on
Nice.
it, and it's making predictions and everything is
Yeah, you're always 10 steps
fine.
ahead, aren't you? Always.
Rich, you were talking about being busy at
Yeah,
the start
yeah,
of the meeting.
yeah.
And I was thinking of telling you that being busy is a bliss in itself.
Yep, it
So
is. Yeah.
the reason that I am like you say ahead of everything in these days, because I have so much time on my hand. I have like nothing else to do.
Cool.
So yeah, but so this I implement everything that comes into my head, and so it's all because of all of the free time that I have.
Yeah.
Uh,
It's good as well, and it puts you in a position where you're a little bit ahead of the game, so you don't have to worry about there's no, if something goes wrong, you don't have to worry about it because you're already ahead. But it puts you in a good position as well, with especially within Team One, because you can straight away go through how you've built this dashboard and how you put it together for the beginners who may have not, even come across Streamlit or whatever you've used, kind of thing. Yeah, it puts you in a good position, and I think because you're hosting like team calls and whatnot, you've got that to discuss in there, and you can show people how it works and how you build a web application. Yeah, it's good. It's good that you're ahead. And at least you've got that template there, because it's efficient. You're efficient always. That's what I'm trying to say. So yeah, it's all good. It's all
thank
good.
you.
But yeah, it's really, really good. And yeah, I've seen. I forgot to mention as well, Wallace. I've seen your reply about the the 2 Python files I uploaded, the callbacks and the automated plotting. I'll get more content over to you, which explains the code a bit better. I mean, I have made a couple of notes, but they're probably not as clear as they could be. But I'll fire some research over to you. That necessarily, I mean, you could probably use the plotting one in your projects now, to be honest. But the callback one is specifically more suited to the building a model from scratch. But it's always handy to have them Python files, because a lot of the time, if I'm having to build a neural network or a computer vision model, whatever it is, that I always copy and paste that callback over and amend it to what I need it to be. So yeah, there's quite a lot to take in, but I'll try and, because I'll find the resources for it for every step in there as well, because the Keras documentation will explain every part of that particular code in the callback module, but the Keras documentation isn't that great. I hate reading documentation because it's too direct. It doesn't really give you any context if you're going to use it, especially in that Keras one. So I'll find a few articles about each sort of stage, which is a bit more digestible and you know, gives you a bit more context on how to use it and why you use it. But I just didn't want to fill up that code because it's long enough. I didn't want to fill it with comments, so you'd be sat there reading all day. I'll find something separate to that. But it's things like patience, you know, patience and early stopping and things like that. It includes all that, and it is quite good. And it's another way of optimizing a neural network without having to, you know, edit the hyperparameters, if you know what I mean. I don't think callbacks count as hyperparameters. I may be wrong on that. That I don't consider them, because hyperparameters will be like, you know, how many neurons you've got and your activation functions and whatever. But your callbacks are specific instructions to how to train the model, and what sort of you know, how it runs and does it start. Yeah, they probably could be called a hyperparameter. What am I talking about? But I don't class them. I see them as separate things. Callbacks are callbacks. Hyperparameters are hyperparameters. And that's just the way I run it. I could be wrong. Probably will be corrected at some point. But yeah, that's just how I seen it as I was learning. It's just an extra little toolbox to get you to squeeze more performance out of a model. And things like early stop and help prevent overfitting as well. So yeah, it's really quite interesting.
Okay, thanks. It's a really nice resource. Thanks for chatting with us. So
no worries.
I could see it's a lot of work there. So congratulations.
Yeah, well, that's the thing. I'm probably the laziest coder ever. So if I write something that's good, I keep it and use it as much as possible. I hardly type any new code anymore.
Oh, I know the feeling. So I have a lot of PDFs and .py files in my drive.
That's what it is. It's like putting a jigsaw together these days. Once you sort of understand what needs to be done, you know, you don't have to repeat yourself and stuff. You just know what will work and what isn't. Just copy and paste that over and amend it to your use case. I'm terrible for that. But yeah, it's a really good resource just to have anyway. If you have, you know, if you start to work in industry or whatever, and you're using some form of neural network for whatever, having them callbacks there on standby, you just bang them in, change it to what you want, and just see what happens. It's just, that's what it's about. It's experimentation, iterative process, always has been. But yeah, glad you enjoyed that. But I'll get some more definitive documentation on that for you. Won't be a problem.
Okay, thank you.
That helps in preventing overfitting, like the callbacks. Like I recently used it when I was working on the CNN. So yeah, it does help in like preventing the overfitting, and it also like saves a lot of time. Like if a model is not learning, and it stops early.
Yeah.
So it does help with that. So.
Yeah, the early stopping will stop it at a certain threshold where your patience is how long the model will wait before stopping or asking you to stop. Do you know what I mean? The way I've designed that one, it basically says, do you want to continue training the model? Do you know what I mean? Because it's not, sometimes it's not as, it's not, what's the word I'm looking for? Sometimes you might be able to just squeeze a little bit more out of it, and it like manually. And so that's why it asks you. Do you know what I mean? If it's done automated, sometimes it misses a couple of epochs, and you're thinking, could have trained a little bit longer there. But yeah, it just gives you that option.
It's always good to have a user feedback, I guess, but I never used that part yet.
Yeah. I mean, you wouldn't do that in a production model, but you know, once it's just in developing the model, and once you're happy with that, you put the model in production without any of the callbacks or anything, because you only need the save weights and whatnot. So yeah, it's handy. It's really useful for development. But yeah, as I say, I'll get some more documentation for that. I've got 10 minutes left. Has anyone got any questions at all? Is anyone stuck on anything, or does anyone have any uncertainties about where we're going to go over the next 2 weeks or so? Go on, Wallace.
Just to confirm, we have 2 or 3 weeks more.
Well, officially we have 2 weeks, but because there's so much experimentation going on, we can do it for another 3 weeks. I mean, to be honest with you, these sort of projects, I've always liked them to go on as long as people need. It's massively iterative, and when you've got a data set like this and you've got so many experiments and you've got such an active team, it's done when it's done. You know, and like even like on the last project we did, even though the project come to an end and we had the final presentation, people still worked on it and amended it to make their portfolio stronger. So there's no stop at you doing that. You're going to have access to this data and access to your Google Colab, so you can continue refining this long after the project's over. So don't worry about that. I just I do understand that I don't want to steal your Saturday all the time. So yeah, another 3 weeks would probably do it, I think, where we have to meet regularly, and then after that point, you guys can go away with all these resources you have, and you can, you know, improve that model and use that for your portfolio. There's no stopping you doing that. You're still going to have access to all the data in your notebooks and your teamwork that you've put together as well. So yeah, I wouldn't worry about it just coming to an end. The very first project I did with Omdena, I carried it on to use for my portfolio when I managed to fine tune the model and get more performance out of it, and do some data analysis that wasn't previously done in the project. Just because it was interesting, and that's it, and that's what I want from it. You know, if you're a beginner, you can just take the project away when it comes to an end and say, you know, this is what I've worked on. But if you're, you know, more experienced, intermediate to an advanced level, you can take it away and fine tune it to a level far beyond the project and use that as your portfolio piece. So yeah, it's entirely up to you. But officially, let's call it 3 weeks, because it'll give us time to develop the deployments and test the deployments, and then the last sort of week is like the final presentations from everyone. So we all get together, everyone you know, presents what they've learned in the project, what went well for them, what didn't go well for them, how they change that in the future, any shout outs to people that have helped them and things like that. So yeah, the final week is more tying up loose ends kind of thing. It's very relaxed, very casual, just preparing a couple of slides to do for the final presentation as well. Usually goes on for about an hour or two, depending on how many people we have speaking. But yeah, it's quite an enjoyable thing, and it's just a week of reflection as well, because it has been really intense, this one. There's been plenty of work to catch up on, so it's just nice to reflect on that. And of course, I encourage people in that week as well to add each other on LinkedIn and leave each other reviews. Leave me a review and I leave reviews back as well. And you know, that helps strengthen your LinkedIn profile and makes your job hunting much easier, especially if you want to move into machine learning and whatnot. So yeah, the last week's more about reflection and trying to help each other out in that sort of sense. So yeah. But so officially, yeah, 3 weeks. We'll call it 3 weeks. We could probably do it sooner. Oasis already finished the project. I bet. Yeah, he's already done it. Do you know what I mean? He finished weeks ago. But yeah, it's so yeah. That's the answer to that question. So Yeah, got 2 weeks of working hard, 1 week of just reflection time.
Okay, nice. So just another question for my curiosity, right? So I worked before with some classification, first time now with image identification, right? So when I see this data set, we have more classes on what we have. In fact, the more rare, all classes is rare in production side, right? So we have more ham cells than all cells.
Yeah.
I think in production side, but in this data set we have a privilege on the all cells against ham cells, right?
Yeah.
My question is, when we have in production, just from as hypothesis, right? Don't we have some kind of distribution shifts because of this difference?
Yep. So that would be an issue when we come, if you were to put this into production. You've trained this model on a certain distribution of classes, and that will obviously change in real life. So that's when the whole ML ops side comes. If you put this into production in a real life situation, you're going to have to put some monitoring systems in and monitor the data that comes into the system, whether it's batch or streaming or whatnot. I imagine it would be batch. And you would have to check them distributions, and then you would have to calibrate the model on these predictions. Now, we covered calibration on a previous project. I'll reshare them resources because it's very interesting, and especially in the medical field, calibration is very important because it has to take in, like, the calibration. What you're doing is basically, if you have all these, like, we've got a distribution of cells, and just for example's sake, say if 1 in 100 people have this particular type of leukemia in real life, that's your background rate. So what we have to do is get the model to sort of take into account this background rate, so we can draw more sort of insight from our classification. Because if our classification is saying, it comes back and says 10 people in 100 of them samples have leukemia, we know that's very unlikely because the background rate is 1. So that's what we have to do. We have to calibrate the model to what we know the distribution is in real life, and that is all part of the ML ops in production. If we would put this into proper production in industry, that's what we'd have to do. We'd have to calibrate the model. I'll share more resources on that. There's things like isotonic regression that calibrates models and whatnot. It's a little bit more complex for computer vision, but because your team is breaking it down into a sort of traditional classification set, things like isotonic regression could be applied. Now, I don't know whether it's possible in a web app to apply this sort of calibration. There's certain cloud services that allow that to happen. There's ones like Abacus AI, which is a machine ML ops platform, which allows this kind of calibration to run on live models and live data. Not too sure the functionality of Streamlit would allow that, but it's definitely something that we can at least do in our notebooks and see how it works. So yeah, that was a very good question, Wallace. I'll share some resources on that. I've got a couple of slides there, and I've got a couple of papers on isotonic regression. I think that'd be perfect for what we're doing at the moment. But I wouldn't worry about that for now. Let me gather some resources, and I'll put it into the knowledge sharing, and we can experiment with that at the very end and just see how that works in our own notebooks and see how it changes the results, basically. But yeah, good question.
Okay, thank you. It's
cool.
Good. Okay.
So yeah, we've got less than a minute. So if no one has got anything else, we'll catch up on Wednesday. I'll keep an eye on Slack, and I'll make sure that I share all the resources for the callbacks and whatnot, and the model calibration as well. It's quite a heavy subject, so don't worry if it's a bit overwhelming. It's quite mathematical heavy, but it is quite